All right, we're going to look at simple and compound interest. Moving into some financial stuff now. We're going to be spending quite a bit of time in here, like financial formulas. So simple interest, some definitions that we're going to want to remember. Interest is the amount of money that we get paid or that we pay for lending or investing money, or that we pay for borrowing money. So you can think of interest as money that you get paid when you put money into an account. And it's like, hey, thanks for putting this money in this account. We're going to give you a little bit of a bonus. Like, here's some free money for putting your money here. Interest is also the extra money that you have to pay when people let you borrow their money. So when you go to the bank and you say, hey, I need a loan, they're going to say, cool, but we're not going to give you this loan for free. We're going to make you pay interest on the loan. That's the amount of money you have to pay for the loan, basically. Principal is the amount of money that you initially deposit or borrow. So if you put $5,000 into your savings account, when you open it, that's your principal. If you borrowed $5,000 for this semester, that's your principal. That's how much money you had to take out in the loan. Your interest rate is usually given as a percent, and then we're going to have to convert it into a decimal. This usually depends on the principal amount. It can also depend on things like other loans that you have, your credit score, if you have any co-signers on your loans, how long you've had an account with that bank. There's a lot of things that can play into what your interest rate is. So we're going to look at simple interest first. Simple interest is interest that is calculated only on the principal amount. So you put the money in the account or you borrow the money and they calculate the interest only on that initial amount. So the interest, which we're always going to shorthand with a capital I, is calculated by taking the principal amount, which will always be a capital P, times the interest rate times the amount of time in years that you have the money in the account or that you have the loan for. And that T is always in years. So if you don't have the loan or the money in the account for a full year, then that T is going to be a fraction. If it's 5.5 years, then it would be 5.5. So looking at an example, you deposit $3,000 in a savings account at your town bank, which has a rate of 5% simple interest. Find the interest earned at the end of the first year. So we're finding the interest earned at the end of the first year. We are depositing $3,000. And our savings account has an interest rate of 5% simple interest. These are all very important things that I need to identify as I'm reading through these, because these are things that are going to change from problem to problem. These are things that are going to help me identify which formula I'm going to need, because we are going to have many formulas that we're going to be learning throughout this section and future sections. So it's a really good habit to get into, to go ahead and underline the important things, just like we did with a regular word problem, so that we can help narrow down what it is that we're looking at. So we're looking for the interest, and we have a simple interest. So we've only got one formula so far. So interest is principal times rate times time. So the principal is the amount that you deposited. So we deposited $3,000 times the interest rate. Now our interest rate is 5%, but we can't do math with percentages. So you're always going to turn that into a decimal. So 0.05 times the number of years that we're leaving the money in the account. And we want to look at this at the end of the first year, so we're leaving it in the account for 1 year. So at the end of the first year, I would have earned $150 in interest. So I put $3,000 in the account. I don't touch it. I don't add anything to it. I don't remove anything from it. And when I come back to that money a year later, I have an extra $150 in the account. And the only thing I had to do was put the money in there and leave it alone. So another thing we can do with simple interest is we can find the future value. So this is the total amount paid on the loan or the total amount earned in your account. And it's found by adding the original principal to the amount of interest. Now you can do these as two separate steps. You can find the amount in interest and then add it to the amount that you originally deposited. Or you can use this formula and it will do it in one step for you. So A stands for future value. How much am I going to have in the future? P is principal. How much am I depositing / borrowing? R is the interest rate. And T is the time in years that we are depositing or borrowing that money for. So now we have a loan of $2,040 that we took out at 7.5% for 4 months. Find the future value of the loan. So we have a loan of $2,040, 7.5%. Our loan term is 4 months, and we want to find the future value. So I'm going to just scroll back up so we can see that equation again. So the principal is how much we are borrowing. So that's the 2040. Open parentheses, 1 plus our interest rate is 7.5%. We need to turn that into a decimal. Do not ever round these decimals. If I give you 12 numbers past the decimal point and then you have to round that, or then you have to turn that into a decimal, you need to keep all those decimals. Don't ever round these guys. Keep all those decimals after you turn the percentage into a decimal. And then we're going to keep this for 4 months. So I'm going to go into parentheses. So 4 months out of the 12 months in a year. Because it's not 1 full year, it's a fraction of a year. So it's 4 out of the 12 months. So our future value, I can type this in my calculator exactly as you see it. Keep the parentheses where they are. Don't lose any parentheses, don't add any parentheses. And I get $2,091. And that's hopefully what you got as well. So that tells me how much I earned in interest, but then it adds it back to what I originally deposited or what I originally borrowed. So this tells me at the end of the 4 months, I will have paid a total of $2,091. So that includes the interest on that payment. So maybe this was for a new dishwasher or a new couch, something that the loan terms aren't quite as long for. They can be, but they're not always super long. So this is simple interest. You don't earn interest very quickly because it's not calculated on anything that you earn along the way. And it's kind of boring. Compound interest is where things get much more interesting, however. Compound interest is interest computed on the original principal as well as on any accumulated interest. So it doesn't go back to just the original amount. It looks at what you originally deposited, but then it also looks at everything that you've accumulated in interest along the way. So it's constantly building upon itself. This is much more commonly used is compound interest. Not a lot of places actually use simple interest. Most loans, most banks actually use compound interest. And it helps you earn much more quickly. However, it also means you have to pay back more when you are borrowing money. So a compounding period is the period of time between two interest payments, or between two payments, or between when you earn interest on your account, if it's in like a savings account or something like that. So if it's compounded annually, the compounded interest is paid once per year. If it's compounded semi-annually, then the compounded interest is paid twice per year. Compounded quarterly is when the compounded interest is paid 4 times per year. N compoundings per year is when the compounded interest is paid N times per year. So in our formula that we're going to get in a minute, we always look at how many times do we pay or get paid interest in 1 year. And we refer to that as N. So if we get paid interest annually, then our compounding period, N, is 1. If it's semi-annually, then our compounding period is 2. Quarterly is 4. You can have weekly compoundings. You can have daily compoundings. You could have bi-weekly. You could have every 4 months. It could be whatever they decide to do. Okay, it could be monthly. I did not mention that one. Okay, whatever that loan or that account decides is best for it in terms of determining interest. So the compound interest formula says if you deposit P dollars at a rate of R, subject to compound interest paid N times per year, then the amount of money A in the account after 2 years is given by A equals P times 1 plus R over N to the NT power. So if I put my money into a bank account and it's going to pay interest compoundedly N times per year, it has an interest rate of R, I leave it there for T years, this formula tells me how much money will be in the account at the end of those T years. So A is still future value. P is still principal. R is still our interest rate. T is still the time in years. And now this new one that shows up twice in the formula, N, is the number of compoundings, so the number of times they calculate interest per year. Could be one time, could be 360 times. And it's 360 because it's banking days and they don't calculate interest on certain holidays. And then I have down here how you can type this into your calculator so that you get the correct answer. So example, if you deposit $1,000 in a savings account at a bank that has a rate of 4%, there's no if in that sentence, but okay. Find the amount A of money in the account after 5 years, subject to interest compounded once a year, round to the nearest cent. All of this stuff that we're doing right now, we're talking about money. Money is rounded to the nearest cent, which means 2 decimal places. So we're looking at $1,000 in the account, and it has a rate of 4%. We want to find A after 5 years. It's compounded once a year. So I'm going to get into this habit now, and I'm going to continue to do this throughout this section. There's a lot of symbols in here now. So off to the side, before I jump into my formula, I'm going to write out each symbol, and I'm going to identify which number goes with which symbol. And then if I have to do any conversions, I can do that now so that I don't forget to do that when I get into the formula. So A is what I'm looking for. P is the amount that I deposited, so that's $1,000. R is my interest rate of 4%, but I know I can't do math with percentages, so I'm going to turn that into a decimal of 0.04 now. N is the number of compoundings a year, so it's compounded once a year, so it's going to compound one time. And T, it's going to be in the account for 5 years. Now that I've done that, I'm going to actually plug this into the formula. I am less likely to make a mistake when I do it this way. And I'm writing it out in the way that you can type it into your calculator. That doesn't look right to me. .04 divided by 1 to the 1. Oh, that's why. Because I didn't put that in parentheses. That's better. Okay. So 1216.65. So after 5 years, you will have a total of $1,216.65 in this account. Find the amount of interest earned. I know how much I started with. I know how much I ended with. So at this point, to find the interest, I'm going to take the future value minus the principal. So my future value was 1216.65. My principal was 1,000. Whatever that difference is, that's how much money I earned in interest. Because I put the money in there and then I didn't touch it. That's the assumption that we're going to make with all of these. So we earned, I earned, you earned, somebody earned $216.65 in interest on this account over 5 years. So a second example, you deposit $4,200 in a savings account that has a rate of 4%. The interest is compounded quarterly. I swear I fixed that to say is. I swear I fixed that. How much money will you have after 10 years? Round to the nearest cent and find the interest. So it's the same thing we just did. This would be a great place to pause, see if you can work out the problem on your own, and then resume the video. So again, we are depositing $4,200. The interest rate is 4%. Now it is compounding quarterly. How much money will you have in 10 years? So A, P, R, N, and T are all of the variables in our formula. We want to know how much money we will have. We are depositing $4,200. Our interest rate is 4%. We cannot do math with percentages. It is compounding quarterly. So quarterly means 4 times a year. If you think like quarters in a dollar, there's 4 quarters in a dollar. So that's 4 times a year. And we're going to leave it in the account for 10 years. So 4,200 times 1 plus 0.04 divided by 4 to the 4 times 10 power. Oops, that's not right. Times 10 power. And for this one, we get 6253.23. And our units are dollars, so making sure that there's a dollar sign on there. The interest after 10 years is the difference between how much we ended with, our future amount, and how much we started with, the principal. So in this 10-year time span, we earned $2,053.23 in interest. That's not terrible considering you put the money in there and then you didn't do anything with it. So present value, these are scenarios where you have a financial goal in mind, but you don't know how much money you need to put in the account now so that you can reach that financial goal. This is not the situation where you're going to put money in every month. This is, I'm going to put a lump sum in an account today because I need it to earn interest over the next 5 years, 10 years, 50 years, whatever, so that I can have X amount of dollars down the road. We will look later at this type of situations where we're putting in money every single month in order to reach a financial goal. But that's not what this is. This is, I'm going to put a huge chunk of money in a savings account today because I want to be able to go on vacation in a year and I want to be able to have this much money for that vacation. So if A dollars need to be accumulated in T years in an account that pays R compounded N times per year, then the present value P that needs to be invested now is given by P equals A divided by 1 plus R over N to the NT. And just as another reminder, P is the principal or present value. A is the future value. R is the rate. N is the number of compoundings per year. And T is the time in years. And again, there's a calculator instruction on there as well. So how much money do you need to deposit today in an account that earns 7% compounded weekly so that it will accumulate $10,000 in 8 years? So we're going to put this in an account that earns 7% compounded weekly, and we need to have $10,000 in 8 years. And we want to know how much should we deposit today. So that's the principal. We want $10,000. The interest rate is 7% or 0.07. It's compounding weekly. There are 52 weeks in a year, so it's going to compound 52 times in a year. And we're going to go on this trip in 8 years. So using the formula from above, and actually I'm going to write it differently. I'm going to write it out as you would type it into your calculator. All right, so that's going to give us our answer. Whoops. Don't leave out any parentheses, don't add any. Just type it in exactly as it's written. So you would need to deposit $5,714.24 into that account today in order to have $10,000 for your vacation in 8 years. And again, that is, you're going to put that amount of money in the account today and you're not going to touch it for 8 years. You're not going to add anything to it. You're not going to take anything out of it. You're going to put it in an account and you're going to forget about it. And then in 8 years, you're going to set an alarm that's going to go off and say, hey, go take this money out of this account that you forgot about for your vacation or whatever it is that you need this $10,000 for. And that's it for compounded interest with simple interest at the beginning of this section.